Hey everybody, this is going to be a little bit of a primer for homework 4. I wanted to go over some of the things that maybe we hadn't gone over in terms of programming and just kind of ease the process a little bit because there's probably going to be some things that might be a little bit confusing. So for right now, I have my RStudio open. I've set my working directory to my 425 folder, which is right here, and I've read in the KC house sales data. So if I run these lines really quickly, I'll have read in my data and I'll be kind of ready to go. So this is the homework that I was talking about. So here's homework 4. I'm just going to go over a few things from exercise 1. Like for example, unique stuff. Here we have houses appearing more than once, meaning you have to be able to identify houses as unique. And working with dates. So these things are all kind of important and can be a little bit tricky the first time you work with them. So to get started, a lot of times economists want to see, or any data scientist wants to see, distributions of variables. They want to look at the number of unique observations and things like this. So the first thing you usually do is you usually pop open either the data itself like this, or maybe if it's a lot of data, like for example, here we have a lot of data, you might want to just open up the first 6 rows. So here's the first 6 rows. We have an ID number, we have a date, which doesn't necessarily look like a date, but it is, because we have 2015 0225, so this is January 25th, 2015. We have the price of the sale, number of bedrooms, number of bathrooms, square footage, floors, if it's a waterfront, like I said, if it has a view, some conditions, some grade, a bunch of different stuff here. And we have lat long. So the first thing you might want to do is you might want to take a look at maybe bedrooms, right? We want to see what's the most number of bedrooms, what's the lowest number of bedrooms, how often do these things occur? So the first thing you can do is just look at, well, the minimum KC bedrooms. The minimum is 0, the maximum 33, so that's pretty large. And something we can do is say, okay, well, and you can also look at the mean and the median as well. These are fairly standard things that people report, just so you can kind of get an understanding. So the average number of bedrooms is 3.3. Now you might want to do something like this. You do KC bedrooms, and this table, what it's going to do is it's going to tell you how many times 0 occurs, how many times 33 occurs, how many times 3 occurs, 4, 5. And if you run this, you say, okay, 0 bedrooms happens 13 times, 1 bedroom happens 199 times, 2 bedrooms 2,760, right? And this is helpful because you can kind of see that after about 7 bedrooms, it really doesn't happen all that much. Like this 33 bedroom place probably is a typo. It's probably meant to be actually 3. So another thing you can do is you can plot this. Plot table KC bedrooms. And here we can see a little bit better of a distribution because we can see, okay, this is way out there. This is probably not real data. 11 might not even be real, but maybe it's just a very large house. 33 sounds either like a mansion or a hotel or something like this. So we can see the distribution here. And we can also save this. So I can save it as beds. I'll save it as table KC bedrooms. If I save this, I saved it as a table, so it's actually just really a vector. But what I can do this is I can coerce this into a data frame. So as dot data frame. Now I have just a data set of the number of bedrooms and how often that variable occurs. So for example, the 0 occurs 13 times, right? But it just gives us these generic column headers. So maybe I want to change the names of that. I want to do column names, beds. I want to say num bedrooms, and maybe I'll keep it as frequency. So now if I open this back up again, I have new information here. So then again, you can plot this all over again. It'll look a little bit different because now this is a factor variable. So if we look at this, you can see it's a factor, has levels. So if I can do as.numeric, but notice how now we have 12 and stuff. That's because factors are really just relabeled versions of this. So instead I should do as.character. And now we have what we had before. And if I do type equals h, we'll get something very similar to what this looks like. Very similar. So this is a lot to say, just, here's how you look at the number of unique observations and how often they occur. So for example, if I want to know how many unique entries there are for bedrooms, I can now do nrow beds, or I can do length table KC bedrooms, right? So all these different things give me the number of unique entries for bedrooms. So the next thing I wanted to talk about briefly was just talk about this date object. So they look a little bit funky, and we can do something similar as we did before too, where we can do table. I'll just do it this way: table KC date. Now there's going to be a ton of observations now because there's a lot of different dates that this can be. And if I plot this, it's going to be kind of a mess because there's really not much of an order to this. This looks like 2014. Here's more 2014. Here's more 2015. Doesn't seem to be much of an order. Maybe there's an ordering. It's probably pretty unlikely though. So rather what we want to do is we want to convert this to something that we can actually both read and use with R. So for example, in theory, I should be able to subtract these two dates and get the number of days in between, right? It's not going to be the case that that's going to work. So if I do date 1 minus KC date 2, it's just going to yell at me because this is not a date object. This is just a character. See, it has quotes around it, so it's just a character. So we're going to have to use this. There are some date stuff in R already built in, but there's a really nice package, and it's called, I'll read it in, it's called elubridate. And it's all about using date objects and converting text to dates. So for example, there's a really great little cheat sheet online, which I'll put right here. So if you really just look up elubridate cheat sheet, this should come up pretty quickly. It's a GitHub thing. If you also want this, you can email it to me, or maybe I'll put this in the description of the video or whatever. But it has all these different functions for you to use. So for example, if you want to do some sort of math with dates, if you want to just convert stuff, it's pretty great. So the first thing I always want to do is I always want to convert the text I have to dates. So for example, I know that this format is year, month, and then day. So I know it's going to be year, month, day. So elubridate has some pretty nice functions for that kind of thing. So if I zoom in here, if your date object looks like this, you can use year, month, day, hours, minutes, seconds, year, month, day, hours, minutes, or just hours. Here's year, day, month, hours, minutes, seconds. So there's different ways that the object might be formatted, and it can handle all of these things. So this one is month, day, year, right? There's all different ways. So our example, because it has this T, that stands for time, and it's just a bunch of zeros, I know that it has hours, minutes, and seconds. So I can just do year, month, day, hours, minutes, seconds, and I can do KC date. I'm just going to convert the first one for now. So we know the first one looks like this, 2014, 10, 13. So this should be October 13th, 2014. And that's what we get. This UTC just means that there's some sort of time associated with it, but that time is 0. So this is like 12 a.m. or midnight, whatever, on this day. So now if I do all of them, it pretty quickly does all of them for us, all 21,000 observations. So now I can save this as KC date 2. And if I pop that open, we can see that it's calculated all these things for us. Now we have the dates. So now another cool thing about LubriDate is you can also use just year or month. So here you can get the month of the date, you can get the year, you can get all these different things, right? So we can do KC date 2. I can just ask R and say, what's the year of this first one, 2014? What's the year of all of them? And it'll give me the year of every single one. And if I ask for, instead of year, I can ask for month. And I can ask for day. So now what we might want to do is we might want to do plot table KC date 2 and see if it's the same. If it's the same, then that's fine. If it's different, then that's great. We made an improvement. So if we can plot this, it kind of looks the same. So that's fine. But now maybe we want to look at, well, let's look at when the most months, so like what month has the most number of observations. So if I want to plot the number of the table of months, it will give us, well, first of all, let's just run this line. It's just going to say that there was, in January, there were 978 homes sold, February, 1,200, 1,800, 2,200. And if we run this plot, we'll be able to see a little bit of which month is most popular. And we can see very clearly that it looks like month 5 is the most popular. We could do the same thing with days. So we could do, oops. We can put a table there. And we can plot it. So it seems like the 23rd day of the month apparently has the most sales out of any other day. We can see that 31 is quite low. That's because only certain months have the 31st day. So there's all kinds of little things that we can kind of do with LubriDate. But I just wanted to show you guys this thing, LubriDate specifically, and the table function and how powerful the table function is, and how you can use it to find number of unique values, distributions, all different kinds of stuff. But if you have any more questions, please be sure to email me. Don't hesitate to get in touch. The sooner the better.